Good morning or good afternoon, depending on when you're choosing to do math for this wonderful eday. And that is also Brick and Uno trying to tell you hello, and we're hoping that everyone's having a nice eday. Hopefully they will stop barking momentarily. Today we're going to look at experimental probability, which is lesson 10.3 in our book. So experimental probability is another kind of probability. So it's kind of an extension of what we've been working with, which we would really call theoretical probability. So the first thing we're going to do is take a look at our definition, kind of our formula for how am I going to find experimental probability. Then we're going to take a look at an example so we can really see the difference between the probability that we found in 10.2 and the experimental probability that we're doing today. So in our notes, we're on page 154. So if you need to hit pause to get your notebook out, then you can go ahead and do that. I'm going to continue on, and you just pause whenever you need to take a break. So experimental probability. My formula for how I'm going to figure that out, I have the probability of whatever my event is. So remember, a capital P means probability. Whatever's in parentheses is what I'm finding the probability of. So the probability of my event is equal to the number of times the event occurs over the total number of trials. Number of times the event occurs over the total number of trials. So if we would go back and look at our 10.2 definition, let me find that for you real fast. Our 10.2 definition of probability was for equally likely outcomes, which was number of favorable outcomes over the total number of outcomes. So notice now we're talking about trials is our denominator now. So let's just take a look at an example that'll make it easier for us. In 10.2 we were talking about like if I had a spinner or if I was rolling a die, etc. So according to theoretical probability, how many times can we expect to land on each color if we take 8 spins? So if I take 8 spins, I should be able to land on, in a perfect world, I would land on green 2 times because they're all equal. 2 out of 8 reduces down to 1/4. So the probability of landing on any one of these is all equal because they're equal spaces. Today what we're going to see with experimental probability is in real life when I'm actually conducting an experiment, hence experimental probability, and I'm collecting data, what does my data actually tell me about the probability of this event happening? So we're actually going to do this. We're actually going to spin 8 times and we're going to see what happens. So spin 1, I land on, oops, that should be an O. Spin 1, I land on orange. I have no idea why I put blue. That should be an orange. Spin 2, I land on purple. Spin 3, we land on red. Spin 4, red. Spin 5, green. Spin 6, green. Spin 7, red. Spin 8, orange. Alright, so we can actually see that according to our experimental probability, green is actually still going to be 1/4 of the time. But purple is actually going to end up being less. It's only going to be, its probability is only 1/8 of the time. And then red is actually going to be the greatest probability at 3/8 of the time. So again, experimental probability, we're actually doing the trials. We're actually spinning the spinner to see what the real outcomes are. So let's take a look at our examples. So again, sports is a really good one for experimental probability. So in 30 times at bat, Jan struck out 14 times. What is the experimental probability that Jan will strike out at her next at bat? So based upon the actuality of Jan's bats, I want to know what's the probability that the next time she's going to strike out. So I'm looking at, she struck out 14 times. So 14, according to my definition, is the number of times the event occurs. What's the event? The event is striking out. She struck out 14 times. How many total times did she go to bat? 30. And then if I simplify this, I should be able to divide both by 2. So 7/15. So the experimental probability of a strikeout should be 7/15, which is going to be, if I divide that out, will end up being 47% or 0.47. Alright, so you can go ahead and hit pause and you can do this quick check problem. 20 tennis matches against Jenny. Eileen wins 9 times. What is the experimental probability that Jenny wins the match? So go ahead and you can hit pause and do this, and then I will come back on with the answer. So go ahead and hit pause. Alright, let's see what our answer is going to be here. We should have a fraction of 9, because we're looking at Jenny winning the match. So she wins 9 times, so that's my numerator. Total number of times is 20, so that's going to be 9/20, or 0.45, or 45%. Alright, the next thing that we're going to do is we're going to analyze our probability to see if an event is going to seem fair or not fair. So, we are with a friend and we're playing a game with a spinner, and we spin the spinner 120 times. It's a lot of spinning. Which of the following games seems fair? And we need to explain. So I win with yellow and my friend wins with blue. So the experimental probability of spinning a yellow is going to be a numerator of 23. And to find the denominator, remember our denominator is the total number of trials. So actually it tells us up here 120. If it didn't tell us 120 times, then we would have to add up our different numbers. So I would add up 58, 23, and 39. When I do that, I'm going to end up with 120. So I can either look at the information given to me, or I might have to use the data and add them all up. So the probability, or the experimental probability of spinning a yellow is 23 times out of 120. The experimental probability of a blue would be 39. Blue came up 39 times out of 120. So this means that my spinner favors the blue, so the game seems to be unfair. So if they're not equal, then unfair. If they're equal, it'll be fair. Oops. sorry. Alright. Let's take a look at another one. Again, we still have 120 spins that we're doing. And this time, I win with red, and my friend can either win with blue or yellow. So we want to find blue or yellow. So blue is 39. So I'm going to add up 39, and yellow is 23. So 39 plus 23, and that's going to give me 62. So the probability, let's do blue or yellow first since we just added those up. So the probability of blue or yellow is going to be 62 out of 120. The probability of red is going to be 58 out of 120. Since these probabilities are about equal, 58, 62, close, then our game seems to be fair. Alright, so you're going to do an example problem here, and I think we're dealing with the same data. I'm spinning, here's my red, yellow, and blue spins. I want to know, what do I want to know here? Suppose you win with red or blue, and my friend can win with red or yellow. I want to know, is that going to seem fair? So go ahead and hit pause and find that out real fast, and then I will be back to share my answer. So go ahead and hit pause. Alright, let's see what we came up here for our answer. Probability of red or blue is going to be 58 plus 39, which is going to be 97 out of 120. And the probability of red or yellow, red is 58, yellow is 23, so 58 plus 23 is 81, so 81 out of 120, and that's going to be about a 68%, and 97 out of 120 is 81. Those numbers aren't close to each other, so that's going to be an unfair game. But an unfair game that is good for me, because I can win with blue or red. Whee! Alright, so that is our second quick check, and I think that's our last example problem. So your homework for today is going to be PW 415, and we're going to go ahead and do all of those problems. We will check our answers for that tomorrow. If you have any questions, be sure that you email me during office hour times. And that's it for today. Have a wonderful afternoon. See you tomorrow.